Hello, everyone. In the last session, we discussed the customer lifetime value model, and we also saw a great example of how that CLV model can be used as a tool to measure the impact of a new initiative and hence make a decision whether the organization wants to go ahead with it or not. Now, in these slides in this video, I want to go over some of the issues that you can expect to face when you're trying to create data for doing your customer analytics work. A lot of what I talk about will also come in very handy when you are working on your project. And remember, data preparation and making the data ready for customer analytics, it's more than 50% of your effort or your time that is invested in the entire work that you will do. So, your project will be a good opportunity to practice some of that. So let's get started. In this slide, I want to talk about different types of data that are available for analysis. And as you see that we discussed that in order to be truly customer centric, an organization needs to have information about different aspects of a customer. And this is what we call as a 360-degree customer view. And there are multiple ways in which this data can be collected. And I'm going to talk about the main dimensions of these sources. The first one is data related to interactions. Now, this interaction data essentially comes from surveys or maybe even or any kind of an interaction that the organization might have had with the individual. Now, these can be emails written by customers, or maybe the transcripts of the chat that the customer has done with the customer service representatives, or maybe even the click stream data, which is collected by looking at the way people interact with the websites of the organization. Then there is attitudinal data. Attitudinal data talks about the preferences and opinions of individuals. These could be information that is collected via market research initiatives, on social media campaigns, and other research related surveys, which could just be created for the purpose of getting to know people's opinions better. Then there is descriptive data. Now, descriptive data essentially is the most significant data that comes in and becomes available at the very beginning when the customer is fairly new with the organization. Now, this data relates to the demographic characteristics of individuals. It might have information about the education profile, about the ethnicity, about the age, and any of those dimensions. Then there is behavioral data. Behavioral data is basically the richest form of customer data, and it becomes available from the behavior via the transactions that the customer does or the orders that the customer places. Even the payment history or the product usage history is categorized under behavioral data. As you can imagine, behavioral data is one of the most important and rich sources of getting to know the customer better. So this is a list of the main ways in which companies can create a 360-degree view of the customer. On this slide, if you see in this visualization, I want to talk about the process by which the organization basically extracts value from customer data. And as you see in this pyramid, on the y-axis at the bottom, basically you have the lowest value that you can get from the data, and this essentially is the raw data. Raw data in itself is high in volume but very low in value. And as you convert this data into information by marrying the context, and then later on by performing analytical techniques on the data, you convert that data into insights, and finally you come up with recommendations that help to solve the business problem. And eventually, when this recommendation gets implemented and turned into an action, then the companies are able to extract the maximum value out of the customer data. So this is the process by which maximum value can be generated from the customer data that's available to organizations. In the two different examples, one of Harrah's and one of Rosewood, when we talked about the journey when an organization decided to become customer centric, the very first investment was in coming up or creating a central database. And this is what can be called as the single version of the truth. And while it might seem very intuitive, in many organizations till date, it is seen that there could be different smaller databases called data marts, which are created specifically to be used by different departments in the organization. And what happens is that very often the meaning of the different columns or the way the data is interpreted can be different depending on the department that is consuming that data. So in order to get the maximum value out of the customer data, it is important to integrate all of that and create this customer analytical database. And that is the first step of becoming customer centric. Now, there are a few factors that need to be kept in mind when preparing data for customer analytics. And some of those are related to the knowledge about the analytical process itself, okay, and the type of information that will be used in that particular analytical process. But more importantly, what is the business process that you're trying to solve for? So for example, if you are working on an acquisition process, and you know that these are the different pieces of information that get utilized in coming up with the list of people who will be targeted. So when you are trying to make this whole process analytically driven, you need to map out the business process and then start thinking about the tools and the techniques that you would use in order to work on that data to convert it into insights. And during this process, maintaining a good documentation is also very important, because very often in organizations, teams move and people, they rotate across different roles and responsibilities. And in that case, if you don't have a good documentation, it will be difficult to maintain that analytical process. So the first step in doing that is to first come up with the business process mapping. So if you think about acquisition as a business process, from the very first point where you come up with the list of candidates all the way to the point where you generate a targeted list, you have to break it down into smaller steps. So for example, in acquisition, the first step will be related to eligibility of individuals. So you can collect a million records, or you can get a big marketing list, but you will have to first see which of those prospects are eligible to receive the offers that you have in mind. And then you can start applying your predictive models on those individuals to start thinking about which individuals are going to be better profiled for the particular product that you have in mind. So mapping out that process first is the key step in coming up with your analytical solutions. So I want to talk about some of the data problems that are encountered in raw data. And a lot of times organizations have a problem with outdated data or missing data. And you will see a lot of this when you start working on your project. And there could be data consistency issues. And very realistically, in organizations, there are issues related to data availability and access. Especially financial services organizations have big roadblocks related to accessibility of data across the departments. These could be related to the sensitivity of data, but having a good handle on these is very important to be able to efficiently utilize the data that you have available in the organization. So I want to go through a few examples of the type of problems you might have. So one of the problems that I talked about could be related to, missing dictionaries or missing metadata, or maybe data inconsistencies that might be there in the data that is saved. Okay. And dealing with all of these is essentially something that you need to do while exploring your data as a first step before you start applying the advanced techniques on customer analytical data. So, there are a few things which you should keep in mind when dealing with missing information. I'm going to talk about some of these techniques which you can keep in mind when you encounter missing values. So there are some things which you should almost never do, such as throwing out the records with missing values. The other one that you should never do is replacing missing values with a special value. And these things are basically things which sometimes people kind of do, but I don't suggest using any of these techniques in thinking about imputing missing values. Then replacing the missing with typical values is something which you could do in a lot of situations. If you don't have a very special reason to come up with a better technique, you can use this way of replacing the missing values with the mean or the median. And there are many tools which kind of suggest that as well. Okay. And there are some of the other things which you could do as well, like you could come up with the distribution of the particular information, particular column, and then you could randomly choose a value, or you could find out based on a machine learning model, you could come up with a technique that could suggest a better imputation. Okay. The other way to deal with this is to think of data mining techniques that are better suited to handling missing values. One of these is decision trees. A lot of tree-based approaches basically come up with surrogate techniques, in which case, if a particular value is variable has missing values, then the model comes up with a surrogate variable, and that the values of that variable can be used in place of the missing variable values. That's one thing. So when I'm going to talk about different techniques in the course, I will talk about how does this particular technique behave with respect to missing information. And another thing to keep in mind is whether you're using SAS or Python or R, whatever library or whatever module you are using, it's important to know that what is the default behavior of that particular functionality when it comes to dealing with missing values, and that will help you make better imputation decisions. The last thing is that sometimes people partition records, in which case they kind of track the missing values separately, and they could build a separate model for the missing rows. But this definitely depends on the number of observations that have missing values in the data. As we continue to talk about the type of issues that could be found in the raw data, very often in organizations, especially when you are working with techniques that require a lot of historical information, you might see that there could be compatibility issues between the new and the old information. And that is where the documentation becomes extremely useful. Uh, now, uh, when we are working with the data in order to prepare the data for analytics, it makes sense to derive useful variables or features from the existing data columns that you have. A lot of times, this specific activity can make your existing models very, very powerful. But a lot of times, this might also depend on your knowledge of the domain. So, for example, if you are working in a financial services company, and you're working with data related to financial services, your understanding of customer behavior, of the impact of external economic environment on the data and customer behavior uh, might enable you to create more meaningful derived values. But these are some of the techniques which I have often seen being used to derive variables. Some of these are related to standardizing numeric variables by centering and rescaling them, or by converting numeric values into percentile, by turning counts into rates, finding out relative measures, or by creating dummy variables, or by encoding categorical variables into numeric variables. So these are some of the things, options which you can explore even when you're working on your project. While we are talking about deriving variables, I want to talk about another set of techniques which are used to derive, more information from the existing set of data is related to rolling up information to different levels. So let me give you an example. If you think about it, for a particular organization, there could be different levels of data that might exist in your company, such as you could have account level information, you could have household level information, or even for that one customer who has multiple accounts, you will have a customer relationship level information. So you need to think about the right level at which you want to work on the given data. And what we do in customer analytics is we think about what is that customer ID, what is the definition of that customer ID, and we roll up information at that customer level. Now, this requires a certain amount of data processing because you're looking at multiple accounts, for example, and rolling up that information to represent a particular customer. So that's one way in which you can derive new variables. The other thing which you could do is depending on the granularity based on the business needs. So if you want to, maybe in one example, let's say you want to analyze account level data, you want to analyze customer level data, and you also want information at household level. In that case, it makes sense to roll up information at multiple levels. Okay. And another dimension across which you can think about rolling up information is along the time dimension. So does it make sense to look at weekly data, or does it make sense to look at monthly or yearly data? This is another set of decisions that you need to make. So if you're working with e-commerce, for example, it might make sense to roll up data at daily level because we know that that information gets updated extremely quickly. But then there could be other products, maybe subscription magazine subscriptions, for example, where it makes sense to roll up information at the monthly level or maybe yearly level. So this is something which depends on the type of business and industry that you're looking at. I'm going to skip through these. You can read through these. These are some examples of the type of derived measures based on the techniques that I just talked about. Okay. So now let's talk about what do you do when you have massive data in hand, or in other words, when you have a lot of data to work with. Okay, these days all organizations are saving a lot of data, but does it mean that you have to analyze every single aspect of that information? And how do you prioritize which pieces of information should you spend more time analyzing? When you work on your project, this is something that's going to be a very important question, which I have seen students face. So the thing is that uh, sometimes you can think about sampling the data when it comes to choosing the records that you should be working with. And in fact, a lot of times, what I do suggest is that you could work with a sample, you could try out different techniques, and in that case, you could save your time. And once you're happy with the particular technique and its solution, then you could roll it out, or you could work on the bigger data set at that point in time. Then, with the same thing in mind, we talk about the technique of oversampling. So, what is oversampling? Oversampling happens when you are analyzing a rare event. So, a rare event, such as, let's say, you wanted to come up with an analytical solution to predict fraud. Now, we know that fraud is essentially, for many big organizations, it is a very rare event, which could be in basis points or maybe like 0.50% of the times of the entire data. In that case, you could oversample the records that represent fraud and undersample the ones that are not fraudulent. And then once you've figured out your model, you can bring the data or scale it back by applying the appropriate rates. The other thing is related to the curse of dimensionality. So what happens is that a lot of times there could be a lot of columns in your data, but you need to think about that which columns are redundant. And identifying redundancy is very important. You might have gone through a couple of techniques in your prerequisite course. And one of the techniques which SAS is very good with is related to variable clustering. So what happens in SAS is that there is this particular functionality, an algorithm, which is a black box within SAS. It's one of the SAS patented algorithms, which helps to cluster variables. And it also suggests to you that within a cluster of variables, which is the best variable that you can use. And that helps to reduce the redundancy in your data. So now let's talk about what should customer data really look like. Okay, now we're actually talking about tabular data in this course. So we're talking about data which is structured and which is represented as rows and columns. So let me talk about what is it that we want this data to look like. Okay, so some of these some of these slides are talking about the type of information that you need to look out for. So for example, if you're doing a predictive model, then you will have a target column, or you would have input columns, and then there are other columns that you can reject or you could ignore, okay, depending on the type of values or the meaning of those particular columns. So let me come to this particular slide where we're talking about customer signature. Now, customer signature essentially provides a snapshot of customer behavior. Customer signature represents the data at the customer level. So each row represents a customer. So when you will be working on your project, you might have transactional data, or you might have product related data, or you might have customer profile data. What you have to do is you have to bring it all together at the customer level to represent one customer as a single row. And to do this, you have to have a good definition of a customer ID. That becomes very important. So let's talk about what are some of the characteristics of a customer signature. So the primary key or the unique identifier for a customer signature is the customer ID. And a lot of times I have seen organizations struggle with defining a customer ID. Let me give you an example. Suppose you are an airline and there is a person who flies on the corporate trips, and the person also flies for personal vacation time. Now, if you define a customer ID, then do you take into account the corporate expenditure along with the personal expenditure at that same level, or do you want to split that? So this is just to show you an example of situations where, as a company, you will have to think about what is the appropriate definition of a customer ID. And then once you have that, then you start collecting the right columns together. Some of those columns are target columns, basically things which you are interested in predicting, could be related to churn activity, could be related to spend behavior. And then there are foreign keys, or keys that help you access other data in which product details are stored, or maybe in which lot of other information related to the customer profile might be stored. But basically, having a customer signature is a must in order to do, in order to work with customer data in the most appropriate manner. So uh, so let me go through some of the things which you need to keep in mind while creating a customer signature. Okay, so the first thing is that you want to identify the definition of a customer. That is the first thing. And then after that, you start collecting inputs and pivoting information from other related tables, and also derive the variables that I had talked about on the previous slide. So lastly, I want to talk about customer data protection. Now, this is something that we had an online discussion on the topic as well. And what's important is that if you think about it from the corporation standpoint, the company is always thinking about what can be collected, how should it be stored, and how can I use that or make that information useful. But from the customer standpoint, you're really thinking about that, do I know everything that's getting collected? Do I know exactly how is it being used, when is it being used, and who are the people who have access to using that? And that is where the Personal Data Protection Acts have come into the play, and it's something which is taken very seriously by the governments and also by the organizations. So I will end the video over here. And this was just a very short summary about some of the things that you need to keep in mind when you start preparing data, customer data for analytics. And a lot of these pointers you will see or you will apply them when you are working on your project. Thank you.